Hello, everybody, and welcome to today's presentation, Change Data Capture, your modern alternative to Scoop for data lake ingestion, brought to you by Attunity. Before we get started, I'd like to take care of a couple of housekeeping items. First off, I'd like to make sure that everybody can hear me okay, so if you would, just send me a quick message in the chat window to let me know that you guys can hear me just fine. Great. If you have any questions today for our presenters, please post those into the questions panel so that we can get them answered after the presentation. If you experience any technical difficulties today, like the audio dropping out or the screen sharing not displaying properly, please post a message in the chat panel and I will work with you to resolve those issues. Finally, on this list, we're recording today's presentation and we'll be making it available shortly after the event concludes. Now that we're through the housekeeping items, I'd like to introduce to you our first presenter. Kevin Petrie is a senior director at Attunity and has 20 years of experience in technology with a focus on big data in the cloud. He has held leadership roles with EMC and Symantec. Prior to receiving his MBA from Haas School of Business at UC Berkeley, Kevin was a financial writer with TheStreet.com, analyzing the data networking and telecommunications industries. Now I'd like to do a quick sound check for Kevin. So Kevin, if you would just like to say hello to the audience, and audience, please let me know if you can hear Kevin fine.
Hi everyone, great to be here.
Awesome. Manish Parikh is a senior solutions engineer at Attunity. Manish has been in the big data space for the past 5 years, and prior to joining Attunity, spent time in Hortonworks and Bank of America. Now I'd like to do a quick sound check for Manish. So Manish, if you would like to say hello to our audience, and audience, please let me know that you can hear Manish fine.
Hello, everybody.
Fantastic. Without further ado, I'm going to turn things over to Kevin so we can begin our presentation, and thanks for listening to me talk.
Very good. Thanks, Andre. So it looks like I am now presenter, and I'm going to go to full screen mode here. So folks, thanks for joining us today. I'm really excited to talk to you about Scoop because we hear about it from customers a lot. There's a vibrant open source ecosystem out there. We're heavily invested in that ecosystem. Apache has several hundred projects that are actively developing some pretty innovative processes for organizations that are innovating with streaming systems and data lakes, and Scoop's an important part of that. There are some considerations about how best to optimize data integration, which you can view as the circulatory system for your analytics architecture. And I want to walk through those based on what we find customers learning, their best practices and their lessons learned. So as Andre said, we introduced ourselves here. I'm Kevin Petrie, and we'll have Manishs Parikh doing the demo so that you can roll up your sleeves and see what we're actually talking about here when the rubber meets the road, if you will. So there are three fundamental shifts taking place in data architectures today. Traditional methods of handling data and analyzing and structuring data are being disrupted, and none of these will surprise people. But I want to talk through each of them very quickly because it's critical to how we work with organizations and how they can adjust to these changes and turn them into advantages rather than challenges. First is the data warehouse has a new very strong complement, which is the data lake. So the advantage of the data lake is that you've got this cost-effective processing and storage, very distributed, very highly available, and you've got the ability to store data without initially applying a schema to it. Rather, you apply the schema on read later on when you want to do the analytics. So you can store and put alongside many different data types, structured or unstructured. Very appealing to organizations that want to be innovative and figure out how to address new analytics use cases. Batch is turning to streaming, and what that means is that there's an increasingly real-time imperative to see data as it's created or shortly thereafter, because the value of data is perishable, whether it's for a strategic decision or a moment-based decision. Someone walks into a store and you need to make a cross-sell effort. Either way, that data needs to be fresh. And so that's driving a move from batch to streaming. What's also driving a move from batch to streaming, even if you don't need the data to be real-time, is efficiency, because batch disrupts production, slows things down. If you can change batch to incremental drips from your production system to your analytics, you're operating in a much more efficient, scalable way. The third shift here is the move from on-prem to cloud. Cloud is becoming very mainstream. Security concerns have abated. Resource elasticity, cost advantages are driving people to add cloud as a very major component of multi-data center hybrid architectures. And to really put this accurately, we should have a Venn diagram showing data lakes overlapping streaming and overlapping cloud, because most of the organizations we work with have a mix of 2 or 3 of these as their targets. This is a few of the platform options that have sprung up in the last decade to help companies optimize analytics workloads to address new use cases. They're going to these workloads because they need to address these modern analytics requirements, and I'm going to go through those. One is AI and artificial intelligence. The most common variant of that, or example of that, is machine learning, where you essentially, either it's supervised or unsupervised, you're enabling our algorithms to teach themselves, to identify patterns, to spot breaks in patterns, to learn from that, and continually optimize the predictions that they make. You need scale here, because you're often going to have multiple machine learning models that are competing with each other, being scored against one another, and their scores need to be monitored so that you can continually improve the algorithms and the data inputs. You need scale. You need a lot of data for that. With streaming, you need real-time, the ability to put transactions from a database, take that live transaction and put it into a message stream in order to capture perishable value. With cloud analytics, if you're moving stuff to the cloud, you want an efficient transfer, because you don't want to undermine the economic benefits of getting onto the cloud by the data transfer process. There's also a move for self-service, because as the business demands more and more data to be analyzed by more and more people, you can't be too dependent on some talented ETL programmers. And there's finally a need here for platform flexibility, because many of the customers we work with develop a plan and then change it. And they change it because there's a trial and error process. So that's an important thing to keep in mind. So I raise all this just to give you some context before we go into Scoop about what we see happening in the market. Some broad fundamental shifts. Scoop can help in some places, but it's a small part of the picture. So what we seek to do is help enterprises deliver data efficiently and in real time to data lake, streaming, and cloud architectures. We're the #1 independent provider of change data capture. So we support the broadest range of sources and targets with the highest performance and the lowest source impact. We've moved already over 55,000 databases to cloud platforms like AWS, more than anyone. And we're #1 in ease of use. So we are designed to accelerate deployments by data architects and DBAs instead of developers, reducing that dependency on ETL programmers. Our platform breaks into 3 specific offerings. Replicate, which provides the 100% automated method of extracting and loading data, of replicating it, either real-time or in batch across all major sources and targets. And then Compose, which will automate the transformation of data once it arrives at the target, whether it's a data lake or a data warehouse. Finally, we have Attunity Enterprise Manager, which will give you that management and control and analytics of high-scale replication environments so that you can optimize your data flows. So that's a little bit about us. Now let's look at Apache Scoop. This has been a top level, it was promoted to a top level Apache project about 6 years ago. It is designed for bulk transfer of data from relational databases into Hadoop. So same set of primary sources that we work with. A lot of companies, we can support relational databases, we can support mainframe and a lot of other legacy platforms, but primarily a lot of folks are looking to move database data into Hadoop. And if you want to do that at low scale in a cost-effective way, slowly, then Scoop can work. It's manually scripted. You're going to have an ETL programmer that learns this, or a Hadoop savvy person that learns the scripting. It can be an economical way to get started on populating your data lake, and it's played a big role there. But it's largely a tactical solution, and there's some considerations here. It's a free tool. That's great. There's a great quote from Scott McNeely, former head of Sun Microsystems, who said that Open source is free like a puppy is free. And I won't go be that strong. I think open source has some fantastic advantages for organizations. It does bring costs in terms of operational efficiency. So Scoop has a hard time scaling. It can have higher latency, and it can be inefficient for transferring large amounts of data. It really tends to fall down when you try to do real time. So let's dig into more of a comparison here. Attunity, Replicate versus Scoop. I've got 5 parameters. The first we'll look at is incremental update efficiency. So a lot of people use Scoop for what it was designed for, which is full batches. And if you're doing a batch load, you're going to need to disrupt production, ideally during the off hours for potentially hours, or increase latency, or both, and then you're going to have to move it to your target. We have CDC that is very low impact, and it will transfer these incremental source updates with minimal source impact so that you actually don't need the batch at all. Now, if you want to use the CDC option with Scoop, it's query-based. And so what that means is that there's going to be this continual query that's pinging the source database. And when it identifies a change, it's going to identify it because there's a dedicated column that shows timestamps, shows when a particular transaction hit that database. So you've got the extra space taken by the dedicated column within production. You've got the additional overhead of querying that. And then you've also got potentially triggers, which means that when there's a change, there's a trigger, which creates another shadow table, which is a copy of the new transaction. Either way, you're tying up space and CPU cycles on your production system, slowing things down. And that can be prohibitive for large organizations that cannot slow down OLTP applications. We are optimized to make sure that doesn't happen. We are log-based. So what that means is that if you're Oracle or SQL Server, you've got a backup and recovery log, and those transactions are going to be hitting that as they happen real time. We're going to read that log. We're not going to read production. We're going to read that log. We're going to identify and capture and copy those transactions as they hit the log live. We'll send them to the target. So there's no need to tie up production CPU cycles. The time to value with Scoop can be challenging because you've got to need to manually script things. You got to make sure that your ETL programmers are available. With us, with Attunity, the time to value is strong. It's low because we have 100% automation. We can empower DBAs or data architects who don't understand scriptings but understand data architecture to execute these extraction and loading jobs themselves. The TCO with Scoop can be poor due to the manual scripting, due to the requirement of a lot of time from expensive developers. Again, our automation is going to reduce the time and labor involved in training and talented resources. Scale and flexibility. This gets back as well to manual scripting, where if you've got a change to the environment, new sources or schemas, that requires new coding, new testing, or a rollout. And with us, as opposed to Scoop, you're going to have the ability to automatically end endpoints, have automatic change propagation. If there's a schema, if you add a table, change a table, remove a column, other types of schema changes to the source, you can automatically propagate to that to the target. No need for scripting. We tend to look at things because we work with a lot of Fortune 100 companies, and there's really a maturity curve here, a maturity model based on, as with any type of learning effort, there's trial and error, and folks go through phases. And so this is something that could be easily applied to data lakes. You really start with level 1 or basic phase here, basic level. You're going to be doing manual full load replication. You'll have silos. You'll have different processes for different endpoints, and you're going to need to call in your ETL developers to handle things. Production's going to get hit for the reasons I talked about before. And this is where Scoop can make sense, or if you're doing ETL tools and ETL scripting, you can really address these level 1, these basic, or level 2 opportunistic stages, because there's some very basic opportunities, and it's not an enterprise-wide approach to data integration. Now, when we get into level 3 and level 4, things are more systematic. Here, you really want automated CDC so that you're reducing the ETL scripting requirements. You want an agentless approach. You want to be able to apply the same approach to any type of platform, source or target, or adopt different styles. Maybe it's CDC, maybe it's publishing to Kafka, maybe it's a full load. And you'll want the ability to integrate into microservices environments so that you could have a Control-M framework from BMC, for example, invoke and execute a replicate task and execute it within their framework. So these are some of the capabilities that are starting to be required when you take a systematic approach to data integration. You have more data integration, you have a more consistent process, and you have a much lower scripting requirement. And this is the area that we serve. So we minimize production impact as well. Attunity Replicate, and then Attunity Enterprise Manager, which, as I said, optimizes the data flows in those large environments, are really the way to handle things here. Level 4 is transformational. And that is where we're applying the automation to the transformation of data on the target once it arrives there, whether it's a data warehouse or a data lake. So we're further reducing ETL scale and resource requirements. We're auto-creating and updating target tables and schemas. Replicate and Enterprise Manager can help, but more importantly, Attunity Compose can help. This can automatically create data structures within data warehouses or data lakes. Okay, so that's the framework that I want to use before talking about our particular products. With Replicate, we've got that 100% automation. We've got zero source footprint, and it's a very modern user experience that Manish is going to show you shortly. The real-time component means that you can stream live updates. So in the case of something like Kafka, which is a very common pipeline for us to these data lakes, we can publish live transactions. So a database becomes a live feed to Kafka or Azure Event Hub or MapRES or Amazon Kinesis. The universal coverage, I think I've got a couple slides here that's going to show we really support all major platforms. So that's 40 platforms, sources and targets that include all the major database, data warehouse, and Hadoop platforms, as well as legacy systems, which might be SAP, mainframe, might be HP nonstop. And that's all going to be on premises or in the cloud. This is a quick look at our architecture. We reside on an intermediate server that is going to scrape those change logs on the sources, send data, changes, or loads in memory to the set of targets. We'll do light filtering and transformation on the way. Most of the transformation is going to take place on the target. But this emphasizes the zero footprint on source or target. Okay, a quick look at our sources and a quick look at our targets. Each year this list grows. Each year you're going to see more focus on cloud, streaming, Hadoop, the really hot areas. Enterprise Manager is the portal that I mentioned that really broadens the lens, broadens the scope of what you can do in your environment. You have one console for potentially thousands of replicate tasks and hundreds of endpoints, and you do it all through one pane of glass. You can analyze the capacity of Replicate server to help with upgrade efforts. You can optimize performance on both a long-term trend basis or a real-time basis. And you can also integrate with microservices environments via .NET and REST APIs, as I mentioned earlier. So the use cases that this can be applied to are broad. It's data lake continuous ingestion. That's what we're talking about with Sqoop, but it's continuous ingestion that's non-disruptive. It's also pipeline automation, which Sqoop can't do. And then you can apply it to a lot of things that Sqoop was never designed for. Streaming live database changes to message architectures, cloud, SAP, mainframe, all these things that really broaden what you can do as you move up the maturity model with data integration. The final note I want to make here is that, before getting to a case study, is that we can automate a data lake pipeline. And what that means is that it helps to land data real time to HDFS, no question. Once it gets to HDFS, despite all the benefits of schema on read, meaning you don't need to structure it right away, a lot of organizations do want to structure it right away. They want to use something like Apache Hive, which is effectively a SQL-like data warehouse on top of HDFS. We can take that data from landing, we can stage it, create a persistent history, and then we can provision that data to a structured historical data store, operational data store, or a snapshot. And these are subsets that are created to meet analytic requirements. So if you've got Hive, you can automatically create the schema for a data store. And then you can automatically update it through a graphical interface that we provide to perform the ACID merge process. And that means that inserts, updates, and deletes can be handled in a single pass. So you have continuously updated data sets that are ACID compliant in your SQL-like data warehouse on top of a data lake. And that's where you really get into some meaningful transformation that greatly accelerates analytics readiness for data in your data lake. A company that's taking advantage of some of these capabilities is Verizon. They were having trouble with a team of financial analysts, I believe a company-wide team of financial analysts, getting sufficiently real-time data from their Oracle, their SAP environment that was running on Oracle, and putting it into a Hortonworks Hadoop data lake. Their tools that were available were too slow, and as a result, they could not get the insights they needed into how the business was running. What we provided was the ability to look into and decode data from SAP tables, landed directly on Hadoop, and these are pool and cluster tables for SAP. We were able to eliminate manual coding and give them a single data integration platform. So a lot of what we do is about partnerships. We punch above our weight because we're the preferred provider to Microsoft and AWS and others that have integrated with our technology. They go to market with us because we are helping their customers more effectively move data across increasingly heterogeneous environments. A lot of what I'm talking about is it extends across verticals. So we do a lot of business with financial services, we do a lot of business with healthcare, insurance, but the value proposition really extends across the Fortune 2000. And so what I'd want to do now is hand over to my colleague Manishs, who is going to give you a very insightful look into how things operate. He'll show you two methods of moving data from Oracle to a Hadoop file system, one with Attunity Replicate and one with Sqoop. So Manishs, I want to cut over to you now.
Okay.
I'm going to make you presenter. All right, so Manishs, I can hear you.
Okay,
and
perfect.
Look forward to your presentation.
Thank you. Hello guys, everybody can hear me? Fine, hopefully. If not, let me know. And can you guys see my screen?
I can see a tent. Yes.
Perfect. So before I start, what I want to show you, what is my environment looks like before I could jump into the demo. So I'm running my VMs here. I'm running my Oracle VM, and I'm also running the Cloudera VM where I'm going to be doing my demo of Sqoop and more focused on Attunity Replicate, because that's where the focus would be, not on Sqoop, but more on the Replicate, because that's where the substitution will be. So I'm running a separate VM on Oracle, like in real environment, where you will have the separate Oracle running somewhere, and then you will have a separate Hadoop environment somewhere else. So I'll be running that. And then I also have, here's my database. I'll be using this table under a schema called HR. This is the Oracle database. And here's my Hadoop that I'm running, a view that you can see. Basically, there are three different things. I'll be running my demo database is where my replicate will start writing data into. If you look at right now, there's no tables there. And then Attunity is where I'm going to be doing the Sqoop. But like I said, I don't want to focus more on Sqoop. I want to focus more on the Attunity Replicate product, which will be nothing but like here, what you see. This is just a glimpse of Attunity Replicate, and I'll walk you through that through the demo process. Okay, having said that, let me show you what. So basically, what people do is they have to write the Sqoop job. Basically, the Sqoop jobs are basically nothing but. Let me just open up my Sqoop job here. So this is the pen job. So basically, they had to write some kind of scripting, and writing scripting means requires a lot of the schema changes or something happens. Then they got to go back and change it. If there's a deletes in Sqoop, it's really complex to have a deletes coming in through Sqoop. So you have to have a high or peak jobs to do that kind of stuff. So that a lot of scripting will be happening in the in Scoop jobs. And this particular example that you saw was basically for the appends. And if you look at the Scoop full load job, basically that's another job that you can run, to do the full load. And then when the append comes in, you basically just taking the CDC data. But like I said, you can only take the inserts. Updates can come as a duplicates, or as long as you had some timestamp, you can see that. But you have to know what your updates are, and the delete just pretty much ignores it. You have to have Pig or Hive, some kind of ETL tool. If you're not using Pig and Hive to do the deletes things. But with Replicate, you don't have to do that. And I'll show you the continuous thing. So let me just start the Scoop job. And again, it goes to the MapReduce, which Attunity will not do that. That's another benefit. It's the performance, because we do not have any agents in the source systems. So because we have our own dedicated replicate server, and we use everything in memory, so we do not go through the MapReduce process, and that gives you the better performance as well. So just to give you that start here, I'm running the job. Let me just tail it if I can tail the job. There you go. Oh, it's gonna go tail. I didn't even hit it yet. Yes, now it started. Okay, let's look at that. There we go. Let's start this. And it's basically running the job right now. While this is running, let me walk you through the process. Like I said, it's just going right now. And I'm not going to sit here. It should take maybe another minute or so to finish this job. But what I'm going to walk you through is basically my replicate, while this is going through. And give that. So replicate, basically, this is what you guys going to see, that once you have replicate server, you have the UI. Once you have the UI, you basically create your endpoint connection. When I say endpoint connection, means you're telling the replicate what my source and targets are. Again, I do not install any agents on my source. Everything is as a dedicated replicate server, which I'm running in Windows environment right now. So if you look at my source, Oracle source, let me just go to the Oracle source. Here's my Oracle source here. And then Oracle source, basically giving my connection string, what my username password is. And if I go back and I can basically say, okay, I'm using log miner. If I'm using the binary reader, which is something else, we can even have your ASM connection strings. So we are not bound to just one way. We can use any method we need to do that. So once you do that, you just say, okay, can I make the connections? And when I do make the connection, it just says successful. Same thing with the Cloudera or Hadoop, I would like to say. So Hadoop thing. So basically Hadoop target, you basically select a target, go for the Hadoop, give your security. So when you say security, we can basically support Kerberos, because I'm sure 99.9% of the Hadoop security in production, at least, or even 100% in production, will be Kerberized. If not, if you need to Kerberize it, but we basically can support Kerberized system. And if you're using Hortonworks, then we also support Knox if that's your also in your landscape. Once you give your security credentials, we basically use the web HDFS or NFS, depends how you set up. And we just give you a name node information. If it's a high availability, we can even give the high availability information, so that standby name node. So that something goes wrong, we can basically pick it up from there. Port, and then what is your HDFS file target that you want to write data to? So you just have to define that. Once you do that, you basically have your own ODBC driver, nothing more than just a high ODBC driver, which is an open source. You can download from Cloudera, Hortonworks website, wherever you need. And then, your high server 2 port. And then basically we select your databases. So once you click here, it will see the same database that I will see here. As you see, you will see the same databases there. If I can go a little bit faster, because I'm going, well, see that job is still going. I don't know what's it's taking time. Because MapReduce always takes time. So there you go. So that's basically we have whatever database that you want to select. That's all the requirement is. Like as I showed you, there are no tables in the demo database. So basically here I pick the demo database. But here's a cool thing: file format. You may not want to keep your file format in a pure text format. You want to keep in Parquet, ORC, sequential, Avro, whatever your choices are. You just have to tell the Attunity replicate, hey, I just want to keep in Parquet, or I want to keep in ORC file format. You just define it, and automatically we'll know that this is what you guys need, and we're going to pick it up. But in my demo, I'll just keep it text, but you just have to do whatever file format you want to do that. At the same time, we can even say, okay, what block size do you want to write to? My favorite one is keep the Hadoop defaults, but some people, for whatever reason, if you want to write to the larger block size, then what it is, you can even do that or smaller. And here, not to have too many small files problem, for the demo purpose, I'm putting 2 seconds, but you already know what your changes coming in, how often do you want to write to? Because you got to be very careful because you don't want to bring too many small files in your Hadoop because of the memory. So you can say, okay, if it's idle for like 60 seconds, okay, write your stuff, whatever it is, because remember, we do everything in memory. So basically, we don't want to hold on for too long, or basically, if the ideal state reaches to certain file system, file size, so we can basically even write to that. So that way, we basically control not writing too far and not too often, but at the same time, not delaying writing for too long. Once you have that, we basically do the test connections and make sure that we can connect properly with our system. And once that comes in properly, say test successful, I'll show you how that works. Okay, there you go. The job is finished in that. So it's just how long it took you just for one table. But here, I'm going to go going. So now once you finish, it's a successful tick box is here. You're all done. Now what you do is you basically, don't save it right now, you create a new task. Once you create a new task, let's call it demo. Now, I don't know what that happened. Let's call it demo. Because this is Hadoop, we're not going to do apply changes, we're going to store changes because we can't apply because it's not ACID in a lot of places. Hadoop doesn't do apply. This is more for relational database. So we do the store changes. Once you have defined that, it comes back to the task. Now this is a task. Now what you do is you basically tell the replicate what my source and targets is. This is all this step is one-time deal. You do not have to do more than once. I mean, once you set it up, that's all you basically do. So now I'm going to go back and say, okay, here's my source. Here's my Oracle source. Drag it, drop it. Here's my target. And I'm going to pick the cloud arrow. I can even just click it, this black box, and then basically come a black arrow, and it comes here. Now, since this is done, I can go to the table selection and say, okay, here's my HR table. Go back, search on it. And it gives you all the tables that I basically is showing you here. Every single table that you see here is going to be here. Because that's Oracle. So I can say, okay, let's just pick employees, job history, and region just for sake of doing it. Okay, so let's go and say, okay. Then let me move to monitor screen. Oh, before I go to that, remember Kevin mentioned that we do support some minor transformations and filtering. So basically we can come back to it. Again, I'm running too many VMs and it's saying so its performance is not there. So if we double click on that, you can basically do some minor transformation here where I can remove a column. I can even add another primary key. If I don't want to use this primary key at all, I can do that. I can change the primary key from the source and target. Again, keep in mind, we do not make any changes to your source side. We cannot do that. But if I want to add a column saying test column, I can just do that, tell whatever it is, or I can just remove a column. So anything, so that's a minor transformation. Again, we don't recommend too much transformation because it slows your performance down because again, this is a replication tool and not an ETL. It's more of a extract and load thing for that. So when you go to the monitor screen, here you basically see there is nothing started yet. So I'm going to just go and run. It's going to start processing. And data is going to start flowing in. And as soon as this data flows in, I'm going to go to demo screen table, and you will see the tables are going to start creating here very fast. So just give some time. It's starting still. It's collecting the metadata right now. There you go. So it's basically starting the loop, and it's going to, as soon as this is started, it's going to see the tables. Again, this is not a performance demo. It's more of a functionality demo. So do that. Okay, so it's running now. There you go. So 3 tables are in queue right now, employees, job history, and regions. And then it's going to start loading, and then it's going to complete. So it basically, we can tell how many we want to run in parallel or not, but that's what we basically do. So it's going to be start loading right now. Meanwhile, while this is loading, we can basically see here, there you go, one is loading. As if, oops, so if this is basically started creating tables. See, as you can see, my system has gone drastically slowed because I'm running too many VMs. Anyway, so let's see. So one is loading, two is queued up right now. Okay, give some time. There you go. So certain tables are started popping up here. Okay, still going. It should be faster than this, but there you go. So it's completed, and then other stuff is going to come back through. So while this is completed, let me show you what is completed and what basically you can tell my employees table is already completed. Let's just go ahead and basically look at the table, and let's refresh it. There you go. So let's just go and do. Okay, so then once you do that, it basically going to start seeing the data. It's going to do that. And right now, job history is running right now, as I can see that, and region table is going to run very next. So anyway, so basically once that is done, this will basically continuously will basically have this green arrow you see here. That's continuously basically going to start looking at the log. Once the load is completed, it basically we're never going to stop. It's automatically we start reading the logs. And once the logs are, once it starts reading the log, we basically, as soon as the changes comes through, we basically start picking up the data from the log. So we do not have to schedule, we do not have to wait, and I'll start, as soon as this is complete loading, I'll basically show you how that works. And right now, only thing left is probably a small table called region table. So we're basically going to do that. Meanwhile, as you can see, we have the data, it's still going, loading. Again, performance is not in this particular demo, but here you go, the results. So basically you can see all the records are basically in this one now. And again, you see that CT table, that's called change tracking table. So what happens is once you have this data coming through from the CDC data, the insert updates and deletes, it will come through the CT table. And that way you will have all the indication. I'm going to show you very fast soon. We'll have the what is update, what is insert, what is deletes. You can see all those records there too. That way you have all the details in the HDFS, and then you can use the product like Compose, Attunity Compose for Hive to basically create the ODS or HDS, the historical data store, or ODS, or you can even write your own manual scripts to basically, if you want to see put a view, or you can just put a view, like a lot of customers just put a view as long as the SLA is being met. So with that, let's just see how is that job. So all three is completed. Now let me just go and make some changes. So I'm going to go and increase the employee salary. I'm also going to insert 100 records, and I'm going to basically delete what I inserted for now. And then again, I'll probably show you what the column. We can even add a column to a table. So if your data DDL changes on your source side, we can automatically pick it up into Hadoop, which is very unique product. We cannot drop a column in Hadoop because it's limitation, because there is no alter table drop, but we can definitely add a column in there. So with that, let me just show you how that works here in the Attunity. So if I go to this change processing, see that automatically, basically we saw insert updates and delete just came through. So here we did 107 updates, 100 inserts, and then basically, and then also 100 deletes. But how do I see that data? Where do I see it? So basically, if I go back to her, I'm just going to go to the CT table, which is my employee table. That's where all my inserts are going to go through. There you go. So this is my updates. So keep in mind, this is a before image and after image. This is another cool product. So if you want to know what my what is my before image is, you can basically look at that as well. So basically, I can move from here, whatever. So basically, as here you go. So basically, if you can look at this data, it basically come back and say, oh, going too far. So update and before image, you can look at the data like that. So what is the value before it and what is the value after it? You can look at that, right? There we go. So you can basically look at all this data based on that. It's not it, but basically you can look at the data there. If you look at my job history, and then if I run that, it will show all my inserts and deletes. That way you can tell what my inserts and deletes are. So you can identify all your tables that are all the records that are inserted as well as those are deleted. Again, and I also can tell from looking at my Attunity, look, there we go. See, these are all my inserts. And then also, since I also inserted and I also deleted, so it's going to be down. There you go. So you said deletes. So these are the deletes and these are the inserts. So you can basically say that these are the 100 records was inserted, 100 records were deleted. So as you can see, you can look at the deletes, you can look at the inserts also. Now let's look at the description of your region table. So let's just describe the region table real quickly. So region table has 3 columns: region ID, region name, and UD date. Now let's go ahead and add a column. As soon as you add a column, if you look at it here, the DDL will show up, the DDL change here. So once the DDL changes here, so we basically alter table, new column is changed, and the DDL showed up, right? See that DDL? And that tells you that one DDL showed up there. So once that DDL show up, we basically can look it up here and say, okay, let's look at the DDL and let's just refresh this table. And let's see the DDL of a region table. And we added a column called new column on the region table. So we'll see the new column right there. See that? So basically, we automatically pick up the data that you have, DDL data, automatically we add a column to it. So that's the beauty. Now remember, we did not schedule any job, we did not do any programming, nothing. It's all manually, one-time setup, automated everything. Like in Scoop, we have to do manual job, everything. And this is pretty much, we can do that kind of stuff from here. So that's what basically, now if you drop a column, you basically will say, hey, if I drop a column, basically the job will not fail. All it does it basically gives you warning saying that, hey, alter region drop column is not supported. That's all it's going to tell you. It's not going to say, hey, this is not a supported function, let me fail. No, it doesn't. We have a lot of things that we can do, but we basically just give you warnings so that we move on. And again, the table in the column will be still set there in the Hadoop side, but it will be dropped in the Oracle side, in the source side. But that's pretty much it. Even though it comes here as source that because we identify, we looked at it, but since this is a limitation not supported by Hadoop, we're just going to give you the warning. Okay, and then here, this is pretty much done. It took us like some time. And again, I can run the pen job when I basically want to run, and basically that again, it's not continuous. You got to keep schedule the pen scoop job, and it's all manually driven. Okay. All right, Kevin. Can make your presenter back. That's the demo.
Very good. Bear with me one moment before we do that. Sorry, I've got a bit of a hiccup here. Good. So, Manish, really appreciate you walking through that. What we'd like to do now is take some questions from the audience, and we can open this up. I think that Andre, you were going to walk through questions that we're getting from folks who've been watching Manish's demo, as well as hearing what I had to say. Andre, are you there?
I am here. I had a little bit of a hiccup myself. Sorry about that.
No problem.
First question is there any support for Google Cloud?
Yeah, we do support Google Cloud. We support Actually, if folks hold on here, I can show you exactly what we support on the Google Cloud. We've seen a lot less uptake there than we have on AWS, of course, and then Azure. So Azure is making a strong, I won't say comeback necessarily. They did grow faster in the most recent quarter than AWS. AWS is the leader. We're strong partners with Microsoft, and we're doing a lot on Azure as well, seeing a lot of demand there. So with Google, what we support is Google Cloud SQL. And there's additional Google platforms that we're looking at supporting as well. So great question.
Okay. Another question is, what more value does Attunity Replicate provide against Oracle's Golden Gate?
Great question. We love competing with Golden Gate. Where to begin? So Golden Gate was bought by Oracle in 2009, and since that time, there's been a progression where they are really optimizing for Oracle environments. So if you're looking at doing high transfer Oracle to Oracle scenarios, that might work for you. If you get into heterogeneous environments, ease of use becomes a problem because less and less is automated. They also have challenges with some of their partnerships simply because they have their own competitive platform. And so, for example, Microsoft about a year and a half ago ended its arrangement for Oracle to be able to read SQL Server 2016 logs and thereby do efficient CDC out of SQL Server 2016. The resulting workaround that they have creates shadow tables, triggers, and has a lot of overhead. It's slow, and it also slows down the production system. If you look at the cloud, Oracle has skin in the game where they want you to go to Oracle Cloud. So they'll force people to pay twice what they would otherwise pay to take something, an Oracle database, to the AWS cloud. So those are just a few of the considerations: ease of use, lack of automation, lack of real heterogeneity, and then a real cost penalty if you're trying to move to non-Oracle cloud.
And Kevin, this is Manishs, and I also want to add one more thing. Yep. Also is the agent. So we are completely agentless software versus Golden Gate requires agents for any of the source system. They need to do that. So, so that also gives you a lot of benefit from our perspective, because we could put no load on your source system, because we do not put any agents on your source systems.
Yeah, no, exactly right. They say there are some sources that don't require agents. What we see in the field is agents are almost everywhere. Even if it is agentless, it's a lot harder to set up.
Okay.
Great stuff.
Another question from the audience: is it possible to do CDC between SQL to SQL or Oracle to Oracle?
Yes, it is, and we sell into a lot of those scenarios.
Yeah, so this is Manishs again. So remember when I showed you how the source and targets are? You can have your Oracle source and Oracle target as well, or you can have SQL Server to SQL Server. So all you have to do is just define your source and targets. It doesn't matter what it is, whatever your source and targets is. It could be same Oracle to Oracle to SQL Server to SQL Server. And those are very common use cases as well that we support right now, also supporting them fit.
Okay. Next question: how does Replicate handle ordering of changes, for example, to maintain foreign key relationships?
So basically, we are log-based CDC. So the way we do it is basically as soon as it hits the redo logs, for example, in your Oracle, the way it comes in, as whoever hits first, that's what we basically do that. So it's a continuous log-based CDC. We do not follow anything else. It's just we basically read logs. If the logs has the first CDC came in, we'll basically apply that thing, and we basically follow that log and do that. So we do not hold anything back. It's a log-based CDC basically.
Here's another, it's kind of a log-related question, but does CDC transaction log reading put any additional overhead on a transactional system? And do you support all RDMS and NoSQL systems? Yeah,
so this is Manishs here again. So we only support MongoDB as a target, but that's pretty much that we use from the NoSQL database. There we go. But so that's only our NoSQL. I'm sure others, like Kevin said, that this list is increasing every day, every
It
quarter
is.
probably. So,
That's correct.
yeah. And what was the other part of the question?
I think, let me go back to it. Does CDC transaction log reading put any additional overhead on a transactional system?
No, we just
It really doesn't. I think we're looking at 1% or less in most cases. And Manish can keep me honest based on what he sees in live customer environments, but it is minimal.
It is. I mean, only time we see a little bit load on your system is when you do the full load, because full load takes some CPU and CPU side. But once the full load is complete, because that's pretty much one-time event anyway, and then the CDC is pretty much, we just need the logs. We don't put any load on your system. So we basically put logs and we take the transactions there. So we see hardly any uh, delays on your sort of put on your source systems.
Next question is, how do you recommend developing transformations that are reactive to change data?
Manish, you want to take that?
Yeah. So when you, I'm just trying to follow up the bit question more. So basically, like I said, whenever the source is making changes, so let's say if the source is making change and they did not hit the commit statement, we will basically hold the records into, we know that it's a change is coming, but the commit is not made. So we basically don't take the data and replicate into the target system. We just hold on to it. And then again, there is a parameterized that we can say, okay, after so much time, we want to flush it out, unless somebody hits, and once they start hit commit again, then we can pick it up again from there. But we basically don't do, and there is no other mechanism, which is log-based CDC that we follow. And we basically pick up the data from the logs. If it hits the log in the redo log files, we just pick it up and do that. And also we have archive logs. If redo log is not option, we can also have option to read from the archive logs.
The questions keep flowing in, so here's our next one. What are the prerequisites? What are the prerequisites? Yeah, now I can't say the word again. What are the prereqs in source databases to use CDC?
That's a great question. So yeah, so there are some prerequisites, and once, if you want to follow, there is a lot. We need, of course, the database has to be in archive log mode. Supplement logging has to be turned on. If you don't want to give us the option to do it automatically, you have to turn on based on which table you want to replicate. And there are certain permissions that you need to provide to the Oracle user that you are defining in the endpoint. So yeah, so there are some prerequisites, and it's not just one, but we can provide the list of all the prerequisites that we require from your DBA to give us, or not give us, give the user that is using to access your data. So that way, it basically allows us to read the log. So that prerequisite is required, and we basically work with the customer once they want to do the POC or go into production. We work with them hand to hand on that one. But yes, it is required.
How does Replicate handle networking issues such as a disconnect or slow networking speed while transferring the data from one system to another?
Yeah, so basically, again, if it's like I said, so we have a procedure. Kevin, can you go to the architecture slide, please?
Yeah. Yep, there we are.
There you go. So look at this architecture slide. And so basically, if there is a slowness or something, we can also we can spill to the persistent store. And again, once we start seeing that, basically there are triggers, alarms that you can define, which I did not show you about in this demo, but then you can define to give some alerts in that one, saying that, hey, this is happening. So that way, you basically have some idea that what something is happening. But what happens is basically your CDC data will keep coming, it's going to keep coming through it. And if it's, for whatever reason, your target is down, or if it's very slow and can't catch up, there is a delay that basically show on your graphic. If you look at the graphic that I have, if I remember, it basically says that this is delayed that much, so we are catching up from that perspective. So you can tell that there's something wrong with the network or something happening. So we need that time to catch up. So we write to the persistent store, and we also see on your dashboard that how much delay we are based on the networking issue or any other issues.
And a couple more questions. I think we kind of touched this, but is your solution certified by Hortonworks?
Kevin, you want to take it? I can talk. So Hortonworks, we are the partner of the year with Hortonworks, and we work hand to hand with the Hortonworks customer. Matter of fact, I come from Hortonworks, and I have worked with many customers. Like for example, Verizon is one of our flagship customer, and many more. So yes, we are certified by Hortonworks, and matter of fact, we are also the supplier, or not the supplier, but, or whatever they call us, for the year, and along with Big Blue and other companies. So we've been blessed with Hortonworks that they recognize our solution. But yeah, we are certified.
Yeah, absolutely. And we work very closely with Hortonworks. We've got a number of reference architectures that have been vetted by their CTO because we work with them quite a bit. And we're integrated with Dataplane. We're integrated with NiFi, and have co-authored a book on NiFi for Dummies. So lots going on with Hortonworks.
Okay. And looks like the last question that we have so far is, does Attunity replicate support SAP?
Yes, definitely.
Oh, we most certainly do.
That's Verizon's biggest use case. Was reason why Verizon even called us for SAP. So because there was no tool out there beside SAP Data Services, which they didn't want to use it for whatever reasons. So they basically looked at us, and that's where we came in. So we can take data from SAP to any of your source systems that you, target systems you wanted.
Fantastic.
And by the way, we support HANA too, just in case if that's the question that people want. So we do support HANA as well, not just SAP ECC, but we also support HANA.
Correct.
One more question just came in. Okay. If there's no log to leverage the CDC technique, is it possible to perform incremental data with Attunity?
Yeah, great question. So there are cases with data warehouses in particular where they oftentimes don't have logs. So Teradata is one, and there are others. So in those cases, what we'll use is queries. We'll query the source data warehouse in order to identify the latest according to a timestamp in a dedicated column or whatever the method is in that column on the production table to identify the latest incrementals and send those over. So we use logs wherever we possibly can. There are some cases like Teradata where we cannot.
Yeah, I'm just going to wait a second to see if anybody else has any final question.
Fantastic questions.
Here's actually a big compliment. Thanks, you Attunity guys. Always have great graphics and clear, interesting webinars. So thank you, John, for sharing that live feedback. Appreciate
it. John, we appreciate that. Sometimes you wonder if you're the tree in the forest, so that's very nice.
Well, if there's no more questions, I'd like to personally thank Kevin and Manish for a great presentation, just to echo John's comments as well. I'd also like to thank today's sponsor, Attunity, for providing the D-Zone audience with a great webinar presentation. And lastly, I'd like to thank you, everyone who's joined us today for the presentation. We hope you learned something new today that will help you in your developer career. And we hope you have a great day, and we'll see you next time. Thanks, gentlemen.
Thank you.
Thank you very much.